Okay, so reviewing 3.6 polynomial and rational inequalities. So we're going to do one of each. So when we solve each inequality, remember we always want to start off with just solving for x. So with our first one, 3x squared plus 16x is greater than or equal to -5. We first want to get everything to one side. So we're going to add that 5 to the other side. So we have 3x squared plus 16x plus 5 is greater than or equal to 0. And then since we have a quadratic, we're going to want to factor. So we're going to do AC factoring. So 3 times 5 is 15. And our factors of 15 that add to be 16 would be 1 and 15. So 3x squared plus 1x plus 15x plus 5 is greater than or equal to 0. And then we're going to factor by grouping. So the GCF of 3x squared plus 1x is just x, and we're left with 3x plus 1, plus our GCF of 15x plus 5 is 5, and again left with 3x plus 1. So our factored form, 3x plus 1 times x plus 5 is greater than or equal to 0. So if we wanted to solve for x, 3x plus 1 equals 0, and x plus 5 equals 0 would give us the x values of -1/3 and -5. So now we know when we look at that graph that those are our x-intercepts. So I'm going to go over here and I'm going to make a number line. And we have -5 and -1/3. And we want to find test points that are going to be in between each of those. So we're going to use -6. Let's use -1 and 0. And so we're going to test each of those values. And remember, we always test those by plugging them into our original. So we have x equals -6. So we have 3 times -6 squared plus 16 times -6 is greater than or equal to -5. So let's see here. -6 squared, that's going to give us 36. And if we multiply that by 3, we get 108. And then 16 times -6 is going to give us a -96, which is greater than or equal to -5. And 108 minus 96 is 12, which is greater than or equal to -5. So this is a yes. So true. So when I come up here, I'm going to put a T. All right, so now if we test x equals -1, we have 3 times -1 squared plus 16 times -1 is greater than or equal to -5. -1 squared is a +1 times 3 is 3 plus 16 times -1 gives us a -16 greater than or equal to -5. And 3 minus 16 is -13 greater than or equal to -5, which is false. And then test x equals 0. So we have 3 times 0 squared plus 16 times 0 is greater than or equal to -5. Since these will all cancel, we're left with 0 is greater than or equal to -5, which is true. So if we wanted to shade in where our solutions are, they would be anywhere where this true statement is. And then we need to decide, do we have parentheses or brackets? So remember, we're going to come back and we're going to look at our original inequality. And since it has that equal to sign, that means we're going to have brackets. And then we can write our solution in interval notation. So we have negative infinity to negative 5, bracket, union, bracket, negative 1/3 to positive infinity. And that is your answer. Okay, looking at our second example, if we look at a rational inequality, again, the first thing we want to do is simplify and move everything to one side. So we're going to start off with subtracting that 3. So we have x plus 4 over 2x minus 1 minus, I'm going to write this 3 as a fraction, so 3 over 1, which is less than 0. So remember, when we're subtracting or adding fractions, we have to have a common denominator. And here, our least common denominator is going to be 2x minus 1. So we need to multiply this second fraction by the 2x minus 1. So we have x plus 4 minus 3 times the quantity 2x minus 1 all over that common denominator of 2x minus 1, which is less than 0. So we can distribute. So we have x plus 4 minus 6x plus 3 over 2x minus 1, which is less than 0. And then combine like terms in our numerator. So we have negative 5x plus 7 over 2x minus 1, which is less than 0. Okay, so now that we have it simplified into one expression, we're going to take our numerator and we're going to solve for x. So if negative 5x plus 7 equals 0, then we know x is going to equal 7/5, which is also 1 2/5, or 1.4. And then if we take our denominator, we have 2x minus 1 equals 0, or x equals 1/2. And that's what we're going to then use for our number line. So we have 1/2, and I'm going to write the mixed fraction, 1 2/5. Okay, so we need to figure out our test values. So let's use 0. Let's use 1 and 2. And again, remember, we're always plugging back into our original. So if we test x equals 0, we have 0 plus 4 over 2 times 0 minus 1 is less than 3. So these are going to cancel. So negative 4 is less than 3, which is true. If I can spell true, it's helpful. Okay, x equals 1. We have 1 plus 4 over 2 times 1 minus 1, which is less than 3. 1 plus 4 is 5. And 2 times 1 is 2, minus 1 is 1. So 5 is less than 3, which is false. And x equals 2. 2 plus 4 over 2 times 2 minus 1 is less than 3. 2 plus 4 is 6. 2 times 2 is 4, minus 1 is 3. And 6 divided by 3 is 2, which is less than 3, so this is true. So we can go in and we can shade where our true values are. And then figure out, do we have less than or greater than? Since we have, if we have parentheses or brackets, since we have just less than, we know we're going to have parentheses. Okay. So our solution is negative infinity to 1/2 union, and I'm going to write that improper fraction again. So let's see, we had 7/5 to positive infinity. One thing to remember, if we would have had a bracket, so if this was less than or equal to, we would have a bracket. Okay. And when that happens, we have to be careful about our denominator. Okay. So remember, our denominator cannot equal 0. Which means at x equals 1/2, there would be a parenthesis. Not a bracket.